In this video we're going to be looking at quadratic equations and problem solving. Actually we'll be looking at 2 of 4 different ways to solve a quadratic equation in this particular video. The first way we're going to look at is using factoring. Solving quadratic equations using factoring. We have got what's called the principle of zero products. So if I have a statement A times B equals 0, this is true if and only if A is 0, B is 0, or they're both 0. So for me to factor, I really have to get all terms to one side, and then I factor. So in this example, I have all my terms are already to one side, zeros on the right hand side. It's a binomial, so the only thing I can do here is factor out an x. Set each factor. Here's A, this is B, so I set them individually equal to 0 and solve. So x equals 0 or x plus 7 equals 0. This one's already complete. This one I need to subtract 7 from both sides. So my solution for this is x equals 0 or negative 7. In this problem, I've got x squared. I need to move the 10x over to get it in descending order. And go ahead and put it where it needs to go. So I've got x squared minus 10x plus 25 is equal to 0. This is one of the nice kinds. My a value is 1. So if I split 25 up, I have 5 times 5. But if you remember, I need to match this sign and number exactly. So my values would be negative 5 and negative 5. So once upon substituting, if you'll notice, if I set the first factor equal to 0 and the second factor equal to 0, they're the same thing. I only need to set one of them if the factors are the same. So my solution here is x equals 5, and it is called a double root, because technically there are 2 of them, but I only need to say it once. So I've got some examples. I need you to factor these, set the factors individually equal to 0. So that means you need to pause me and then bring me back on when you get through. So in this particular problem, all terms are already over to the left-hand side. Hopefully you factored it as x plus 3, x plus 4. Set factors individually equal to 0. Let me just go ahead and get rid of that box. So if you'll notice, x equals negative 3 or x equals negative 4. If you substitute this back in, it will give you a true statement in that it will be 0 equal 0. Hopefully you tried this one. A little bit more difficult. I'll have to move everything over, and you will need a table of values here. But I'm going to go ahead and just do the problem because you've already been through factoring. So I moved everything over to one side. Now if you factor this, you should have ended up with parentheses 4x minus 1, another parentheses 3x plus 5. That's the factored version. So hopefully you ended up with that. Set them individually equal to 0. And you should have x equals 1/4 here and x equals negative 5/3 for the next one. Don't look at that. So on this one, it's not in the correct form. Bring everything over. So you have 100 x squared minus 121. It's a binomial, so it's a difference of perfect squares. I should have 10x plus 11 and 10x minus 11. Okay? Set them individually equal to 0. So this one would give me x equals a negative 11/10. And this one would give me x equals a positive 11/10. So that's how you solve quadratic equations by factoring. And I will have specific ways that I want you to do problems. Your instructor might also. So let me see, that's the first way. The second way on this particular video is solving quadratic equations using square roots. Now this is sort of special in that it must look a certain way in order for me to use this process. The principle of square roots. If for any real number k, if I have x squared, some quantity squared equal k, then if I take square root of both sides, hopefully you remember doing this, you'll end up with x equals, remember the plus or minus, square root of k, because when I take the square root of x squared, I get x. So I've got to have this situation in order to use this particular process. Now I've got two problems here, actually the same problem. One I'm going to solve by factoring and one by using square roots. This one, difference of perfect squares, I factored, set them individually equal to 0, so x equals -6 or x equals 6. And this one, if I can get it in this form, I can take square root of both sides. So I added 36, took square root of both sides. You have got to remember right when you take square root you have plus or minus. And if you'll notice, x equals plus or minus 6, which is the exact same thing I've got here. So sometimes it's quicker to go and use this principle of square roots. Now I've got some examples. Let's see. By using the principle of square roots, we now have a method that can be used to solve equations for which factoring is impossible. So let's see what I've got. 3 problems. So here, if I have to get this in the form of x squared, that means I've got to solve the equation for x squared. So I've got to do some work here. First thing I need to do is add 10 to both sides. Divide by 2. So now if you'll notice, I do have it in the correct form. So if I take square root both sides, I should have x equals plus or minus square root of 5. And if you put it in your calculator, you can get an approximation of plus or minus 2.236. Some instructors want exact, so you have to know what your instructor wants. So square root of x squared, you should have x equals plus or minus square root of 5. So I really didn't finish that completely. Let's look at this one. Notice my x squared is already by its lonesome. So I'm going to go ahead and take square root of both sides. And if you'll notice, there's my plus or minus. You've got to get that in there. So let me go down a little bit more. Now, what I'm doing here is I am simplifying the radical. So square root of x squared is x plus or minus square root of 84. Now, it is your job to break 84 up into its factors, but the factors you need is a perfect square. So if I go 4 times 21, there's my 84. 4 is my perfect square. So 4, I can apply the square root, and I have 2. So technically the exact answer would be plus or minus 2 square root of 21. Now if you put that in the calculator, you'll end up with an approximation of plus or minus 9.165. Now this one is a little bit different from the other one, but if you'll notice, I've got this item squared. I can still use this square root process. So if I take square root of both sides, indicate square root first, remember plus or minus. Now this square root will negate my square, so I will get just m minus 3 out of that under the radical. Now if I'm solving for m, the only other thing I need to do is add 3. Keep moving it down. Whoops, too much. So now this is an exact answer. If you put it in your calculator, you'll end up with the following approximation. That m is approximately equal to 5.449, or m is approximately equal to 0.551. So again, you need to listen to your instructor to see exactly what they want. Okay? Thank you.